Okay, this video covers section 2.5, which is implicit differentiation. All right, so if you look at number 1, it looks just like the problem that we would have done before, right? Y equals the square root, and we're supposed to find the derivative. When we start doing implicit differentiation, we're going to start seeing notation more like this, the dy dx, for the derivative, as opposed to like a y prime or f prime of x. So I would say, all right, the derivative of y is dy dx. And then in order to do the derivative of the right side, we're going to have to do a chain rule, right? So 1/2, keep the x squared plus 1 to the negative 1/2, and then times the derivative of the inside times 2x. And as you can tell, the 2 and the 1/2 will cancel. And so we could write this as x over the square root of x squared plus 1. Okay, just like we've done in the past. But look at number 2. Notice on number 2, we're supposed to find the derivative, but look at the equation. It's x squared plus y squared equals 4. In other words, it's not solved for y. Well, I could solve for y and then take the derivative, right? Just like I did on number 1. But look at number 3. I'm supposed to find the derivative, but this time, not only do I have the x's and y's mixed up, but it's going to be a lot more difficult to solve for y. In fact, for some people, it would be impossible to solve for y. So what we're going to do is we're going to learn a new form of differentiation called implicit. And the idea is it doesn't matter if x's and y's are all mixed up, as opposed to what we're used to, like this one up here, where the y is by itself. So the way it works is implicit versus explicit would be, implicit is when you have the x's and y's. It's not very technical, but I'm going to say all mixed up. Meaning you could have both x's and y's on either side. Whereas explicit is what we've been doing, we just haven't called it that. That's where you have y equals, and then everything on the right hand side would be your function of x, meaning everything on the right hand side is in terms of x. Okay, so basically implicit differentiation is an extension of the chain rule. Now it's not like you have to tell yourself, hey, I'm getting ready to do the chain rule, but that's where it comes from. So if I want to think about number 2 from above, I know I said I didn't need to use implicit, but I'm going to. The way it would work is I would just start on the left, and I'm going to take the derivative of every single term and work my way across. So I could say, well, derivative of x squared, just like we've done in the past, is 2x plus, now the derivative of y squared, if you apply the same rules, would be 2y. But since we just took the derivative of a y term instead of an x term, we have to write dy dx. So basically, every time you take the derivative of a term that's not the x, you just write down your notation. And then on the other side, the derivative of 4 is 0. So here's the thing. If I'm trying to find dy dx, that means I'm trying to solve for dy dx. So in order to solve, I could subtract my 2x. So dy dx is going to equal, oops, I forgot my 2y in front there, is going to equal negative 2x. And again, if I want to solve for dy dx, I would divide by 2y. So I could say dy dx is negative 2x over 2y. And then I could just cancel and say negative x over y. So when we do implicit differentiation, yeah, we're going to get a derivative. So this dy dx is the same as saying y prime or f prime. But this time, the answer could very well be in terms of both x and y, unlike what we've done in the past where we always had just x's on that side. Okay, so take a look at number 3 from above. Remember on this one, we said we had to come up with another plan because there was no way we could have solved for y even if we had wanted to. So what we can do is just start on the left, and we're going to take the derivative of everything all the way across. So the derivative of 4y is 4, but because it's a y term, you have to write dy dx. Keep going, plus The derivative of y squared is 2y. Again, because it's a y term, you have to write dy dx. And now I see this xy. Well, keep in mind that's a product, so I'm going to have to do a product rule. So I'm going to bring down the minus, and then I'm going to do a product rule in parentheses. That way I can think of my first as just being x and my second as just being y. So the derivative of the first, derivative of x, is just 1 times the second, so times y, plus, still doing my product rule, the first is x, and now the derivative of y would be 1, but because it's a y, I need a dy dx. And then on the other side, the derivative of 10 is 0. Now remember, we're trying to solve for dy dx. It just so happens that I have 3 dy dx terms. So I think I'll go ahead and distribute that negative. So I've got 4 dy dx plus 2y dy dx minus y minus x dy dx, and this is all equal to 0. So what I'm going to do is I'm going to keep all my dy dx terms on the left, but I'm also going to factor out a dy dx, and in the same step I'm going to move this one term right here that was not a dy dx. I'm going to move that one to the other side. Okay, so on the left I've got my dy dx, and I'm factoring out. I would have 4 plus 2y minus x, and then on the right I'm just going to have my positive y. So if we're trying to solve for dy dx, wouldn't I just divide both sides by that entire parenthesis? So I'm going to get dy dx equals y all over 4 plus 2y minus x. Okay, so again, we use kind of all the same rules. It's just that once we find our derivative, we might have both x's and y's in our answer. Okay, so let's do a couple more examples together. Take a look at number 1. Trig works the same way. So I just start on the left, work my way across. The derivative of sine of x would be cosine of x plus, so in order to do the derivative of my 2 cosine 2y, I'm going to bring down the 2 that's out in front, leave that alone. Now the derivative of cosine is negative sine of the same angle, and then the derivative of the inside would be times 2. And now don't forget, because I took the derivative of that 2y on the inside, yeah, the derivative was 2, but I got to have a dy dx because it was a y term. And then on the right side I have the derivative of 1, which is 0. Okay, so I'll clean it up. I've got cosine x. And I'm going to write this as a minus 4 sine 2y dy dx, all equals 0. Okay, so in order to solve for dy dx, I think you can handle this. Not only am I going to subtract the cosine from the other side, but I'm also going to need to divide by this negative 4 sine 2y, negative 4 sine 2y. And I could simplify, right? The negatives will cancel out, and I'm just going to have cosine x over 4 sine 2y. Okay, so that is my dy dx. All right, look at number 2. All right, as I mentioned to you guys before, this idea of finding the equation of a tangent line, that's not going to go away. Almost every problem we do comes back to knowing how to find the equation of a tangent line. So again, what 2 things do we need? Well, we need a point, got it, and we need the slope at that point. So I'm going to find the derivative. Now notice on the left-hand side, I've got x squared plus 4 times y. So I could start off using a product rule. Now, granted, if I wanted to on this, I could solve for y and not have to do implicit, but it's not like it's going to be that much easier. And since we're here to practice implicit, I'm just going to start doing a product rule. So the derivative of the first would be 2x times the second plus the first, which is x squared plus 4, And then the derivative of the second, so the derivative of y is dy dx equals, derivative of 8 is 0. So if I want to solve for dy dx, I'm going to subtract the 2xy, at the same time divide by x squared plus 4. So there's my derivative. And remember, I need the derivative at this point. Well, in the past, all we've needed was the x value, right? But now our derivative could have a y in it. So I'm going to need both the x and the y. So I'm going to use some notation. I'm going to say the derivative at the point 2, 1. And so now I just plug in a 2 for x and a 1 for y. So negative 2 times 2 times 1 all over 2 squared plus 4. Do a little simplify. So let's see, negative 4 over 8. So my slope is going to be negative 1/2. And then if I write the equation of the tangent line, I would have y minus 1 equals negative 1/2 x minus 2. Okay. Let's do one more. This time, I just want to find the derivative when x equals 1. So find the derivative and plug in a 1 for x. All right, so the derivative of x squared is 2x. I'm going to bring down the minus and the 2, and now I'm going to do a product rule on the x times y. I could have, thought of the 2 going with the x and let 2x be the first, but I don't know, I've already got the 2 down there, so I'll leave it alone. So, product rule, derivative of x is 1 times y plus the first, so x, derivative of y is dy dx, and then plus, derivative of y is dy dx, equals, derivative of negative 2 is 0. So, let's see, I'm trying to solve for dy dx. How about if I get rid of these parentheses? So, 2x minus 2y minus 2x dy dx plus dy dx equals 0. And again, if I want to solve for dy dx, I'm going to leave that over here, and I'm going to factor it out of those two terms. So that would be what? A negative 2x plus 1. And at the same time, I'm going to take this 2x and subtract it, and I'm going to take this minus 2y and add it. So I'm going to end up with, let's see, a positive 2y and a negative 2x. So just finish solving for dy dx. So dy dx is 2y minus 2x all over. I know it's a negative 2x plus 1, but I don't know why. I'm just going to write 1 minus 2x. And no, those 2x's cannot cancel. And so I want the derivative at x equals 1, but notice my derivative has an x and a y. So how can I find the y value if x equals 1? Well, we've talked about this before. Whenever you want to find the y value, plug that 1, that x, back into the original. So if I put a 1 into the original function, I'm going to have 1 squared minus 2 times 1 times y plus y equals negative 2. And this is going to allow me to solve for y. So let's see, negative y equals negative 3. So y must be 3. Oh, okay. So my xy is 1, 3, and I'm ready to plug that into my derivative. So I could say dy dx at the point 1, 3. So 3 in for y. So that's going to be 2 times 3, 1 in for x. So minus 2 times 1, 1 minus 1 in for x. So let's see, what is that? 6 minus 2 is 4 over 1 minus 2, or negative 1. So my derivative is negative 4. Okay, so that's just a little bit of showing you how to do implicit differentiation. The homework is a worksheet, that you should, I'm not sure if you already have that, but I'll get that passed out. And then that is due next class period.